Alright, so systems of equations. We've already covered the solving by graphing, solving by substitution, and solving by elimination. Now we're going to go ahead and apply this to word problems. So the thing you need to think about is, remember that equations have variables. A variable is nothing more than a missing number. Alright, it's something that you're trying to find. So when you have a missing number or a number that you can't figure out what it is or don't know what it is, that's when you put a variable in its place. Now, in the case of systems, be mindful that you're using more than one variable. We'll be using x's and y's. Most system word problems are solved using substitution or elimination, but you can still use graphing if it's necessary, and be mindful that graphing might not be the best option, because if you're dealing with something like money and you're going to have decimals involved, you probably don't want to use graphing. All right? So let's take a look at an example here. Jody went to the store and she bought 2 pairs of pants and 4 shirts. Now, before I continue reading, we're playing a little bit of pretend right here. We're going to pretend that all the shirts cost the same price and all the pants cost the same price. So she goes to the store, she buys 2 pairs of pants, 4 shirts. She spends $80. Later that day, she goes back and she buys 1 more pair of pants and 3 shirts, and this time she spends $50. How much does each shirt cost, and how much does each pair of pants cost? So I'm going to go ahead and I'm going to assign a variable to each one of them. How much do the pants cost? How much do the shirts cost? That's the number that we don't know. That's our variables. So for pants, I put X, and for shirts, I assign it to Y. Now, in the first situation, she buys 2 pairs of pants and 4 shirts, and she spends $80. Second scenario, she goes back and she buys 1 pair of pants and 3 shirts, and she spends $50. Now, based on the way that I've set this up, I'm going to use the elimination method. I notice that I don't have a match, I don't have an opposite, so that's why I've got to do the multiplying. Multiply the top one by the 1, and multiply the bottom one by the 2. I do that, and I distribute to all 3, and I get these 2 equations in the green. I'm now subtracting because that's going to get me a 0 right here. We've got a match, so 2x minus 2x gives 0. I can cancel that out. 4 minus 6 is negative 2, and 80 minus 100 is negative 20. We solve that equation and we get y is 10. Turn around and plug it in. I'm going to use the second equation right here. Smaller numbers, right? So using that second equation, I plug in the 10 for y. I get this. And we go ahead and solve the equation. We get x equals 20. So remember what you assigned everything to? That means that the pants were $20 each, shirts were $10 each, and there you have your answer. Okay, here's example 2. At the movie theater, children's tickets are $5 and adult tickets are $10. On Wednesday, the theater sold 50 tickets and they collected $400. How many children tickets were sold and how many adult tickets were sold? So the 2 things that we don't know, the children tickets, the adult tickets, assign a variable. Children X, adult Y. First, we're going to talk about the price. $5 for a child ticket, $10 for an adult ticket, $400 was collected. How many tickets each? We don't know. X children's tickets, Y adults tickets, 50 total. Solve by elimination. Multiplying because we don't have a match or an opposite. We get these 2 new equations. I now have a match, so subtract. That cancels out because it's 0. 10 minus 5 is 5. 400 minus 250 is 150. Solve that, you get y equals 30. Plug that back in. I chose the second equation because it's smaller numbers. Plug the 30 in for y, solve, and we get 20. So what do we know? Well, the children was X, so 20 children's tickets were sold. And the adults were Y, so there was 30 adult tickets sold. Next example. Brandon is 4 years older than his brother Chad. The sum of their ages is 32. How old is each brother? Brandon, X. Chad, Y. Let's talk about the sum. Adding both brothers together, X plus Y is 32. Well, we do know some additional information about Brandon, X. Brandon equals 4 more years than his brother Chad. So Chad's age, Y, plus 4 more years. Based on how that's set up, we'll use substitution. So plug that in. We know what X equals. Circle it, stick it in for the X in the other equation. You get this. Combine like terms. Solve the equation. Y is 14. Plug that right back in to the one you had circled and solve, and you get 18. So who is 18? X. Brandon. Brandon's 18. Chad's 14.